In this video, we're going to discuss combining like terms. So what are like terms? Well, a good definition for like terms is terms that have the same variables and the same exponents on those variables. So what does that look like? Well, let's look at an example. If I have 9a plus 3a minus 2b plus 5b, okay, so I notice I've got some a's and I've got some b's in here, and I want to combine the like terms. Like terms have to have the same variable and the same exponent on those variables. So the first variable I see is an a, and it's a to the first power. So are there any more a's? Well, sure, here's an a right here. So are there any more a's? Well, nope, that's it. So here are all of the terms that include only an a. So we're going to consider those like terms, so we can combine them. And how is it that we combine them? Well, we combine them by adding or subtracting simply their coefficients. So in this case, we're saying 9a plus 3a, which means it's 9 plus 3, and the a kind of just comes along for the ride. So 9 plus 3 is 12, and the a comes along for the ride. Next, we have a b, so I'm going to kind of put a line under that b. Do we have any more b's? Oh, right there. And are they identical? Is it b and only b, and are the exponents the same? Well, sure. We have b to the first and b to the first. I say b to the first when there's no exponent up there. It just kind of means there's a 1. It's kind of understood that way. So since they're like terms now, I'm going to combine their coefficients. I'm going to add or subtract, as is dictated by the problem. So this says a negative 2b plus 5b. Well, negative 2 plus 5 is going to be a positive 3b. So I'm going to say positive 3b. And this is my simplified expression after I have combined the like terms. Okay, so let's try something else. Let's try something with only one variable but multiple exponents on those variables. If I have something like 10x squared minus 3x plus 2 or minus 5x squared plus 7 plus 7x. Okay, we got tons of terms here, lots of them. But don't worry, because all we have to do is combine the like terms. So I'll just start over here at the left and say I have an x squared right here. Do I have any more terms that have just an x squared? Well, sure, here's another one right here. So I'm going to take those two terms and I'm going to combine them, kind of rewrite them. So 10x squared, and this will be a minus 5x squared. Minus 5x squared. You will always take the sign in front of the term. This minus right here comes down to here. It's not because this is a minus. That minus goes with this 3x. This minus goes with this term. The reason this is minus is because before it, the sign before it is what's minus. So the sign before the term will always dictate where that term is, what that term is, whether it's positive or negative, and where that sign goes. Okay, anyway. So we've dealt with our x squareds now. So I kind of cross those out a little bit there. So now here's an x. Do we have any more terms that have just an x? Oh, right over here. So I'm going to combine those, but I'm going to rewrite them first. So negative 3x, so this negative 3x, and this guy's a plus 7x, so plus 7x. Okay, I'm kind of cross those guys out. What else do we have? We have a 2 plus 7. So for the sake of just doing the same thing, I'll just say plus 2 plus 7. Now we have all of our like terms grouped together beautifully. We've got our x squareds here, our x's here, and our constants here. So now we can go ahead and combine the like terms. And as on the last example, how do we combine like terms? We simply add or subtract the coefficients. So 10 minus 5 is 5x squared. Negative 3 plus 7 is a positive 4x. And 2 plus 7 is plus 9. Notice once again that the variables or the exponents on those variables did not change. These x squared and x squared remained x squared. This x and x remained x. The variables and the exponents on those variables solely dictate what gets combined together. That dictates what's like terms with what and what's not like terms with what. The terms themselves and the variables and exponents do not change. It's the same thing as saying I have 3 apples and you give me 5 apples, so I have 8 apples. I don't have 8 apples squared. That's crazy talk. So your variables and your exponents on those variables do not change when combining like terms. Okay, so let's try a little more difficult example where I have some distributive property in there. Okay, let's say I have something like 2 times the quantity 3x minus 5, and I'm going to combine that with 3x times the quantity 2x minus 7. Okay, so I'm going to have some multiplication in here with our distributive property, and then I'm going to be combining some stuff. So this 2 will get distributed first here and here. So 2 times 3x is 6x minus, because the minus sign there, 2 times 5 is 10. So now we're going to take this 3x and combine them here and here. So 3x times 2x. Here we're multiplying variables. So we have 3 times 2 is 6, and x times x is x squared. Notice this time that my variable changed. Well, haven't I been saying for the whole video that the variables don't change? Well, they don't. Whenever you're adding and subtracting, combining like terms, the variables do not change. We were not adding or subtracting. We were multiplying right here, so x times x is x squared. Continuing, 3x times 7, and this minus is minus 21. So now what are the like terms? Well, it looks like, oh, I forgot to put this x right there. Bring that x down. Caught me. So, what are the like terms? Well, here's an x here, and here's an x here, so those are going to be like terms. Are any of the rest like? Well, that's an x squared, and that's just a constant, so nope. So we've got 6x minus 21x minus 10 plus 6x squared. So when I go ahead and combine these like terms, they both have x's, so I'm just going to add or subtract their coefficients. So 6 minus 21 is a negative 15x. Nothing else changes, so it all comes along for the ride. And then, simply because I like to, I'm going to put this in standard form, which means I'm going to put them from highest exponent to lowest exponent. So this 6x squared is actually going to come out front, and I'm going to reorder these terms and put it in standard form. This expression right here is correct, but it's just not in standard form like the way this one is.